go. That's a bit better. That's a bit better. Minimize that, and we'll go back to being live. I'm actually going to hop over to this computer. I'm going to start sharing my screen, start sharing my face. There we go. Man, Facebook could have made that a lot easier instead of me having to hack this together with Python scripts. But hey, that's what the PyImage Search blog is, right? Hacking together with Python scripts. Let me check the office hours page on my laptop over here next to me. And we'll get that going. Start up the video stream. There we go. Got to redo the embed on the office hours page, so anyone who's tuning in on that page will be able to see it. So I'm going to take care of that real quick. The good news is that I understand how to do it now. So next time we do this, it'll be much better. There we go. That's much better. Okay, so welcome to the first ever PyImage Search office hours. Today is Thursday, September 5th, 2019, a little past 2 o'clock. And this is something I've wanted to do for a long time, and I don't know why I'm just getting around to it now. But it just seems like a really good idea that I'd be able to share some of the questions that I get at the PyImage Search blog. The great thing about PyImage Search is we get a lot of questions, which just shows there's so much interest in what we do and what we teach. But the problem with one-on-one email, and this is true for Twitter, this is true for LinkedIn messages, for Facebook messages, is that one-on-one help only helps that singular one person that we're talking to. If you email me with a question, I get back to you and I respond, or maybe I don't specifically, or someone on my team does, and we'll work you through whatever issue that you're going through. The downside is no one gets to learn from that additional knowledge. And sometimes it may take us 20, 30 minutes, an hour to craft like a really good email reply, and only that one single person benefits. So my hope with office hours is to be able to change them a little bit, be able to share some of the questions that we get, share my answers. That way it benefits us all as a community. So why office hours? Why is it a big deal? Again, to provide free help. One of the biggest tenets of PyImage Search when I started it back in grad school was to be able to share not only my knowledge, not only the tutorials and the free guides, but also be able to share my expertise with others. Getting started in computer vision and machine learning, it's not the same as just picking up a new programming language. There's a lot more nuances. There's a lot more things that can trip you up. And it's not just simple math either. It's more advanced math. It's calculus. It's linear algebra. There are a lot more things that can mess you up along the way. And then along with that, though, is when I started PyImage Search in, when was it? I guess it was grad school. It was my final semester of grad school. I was at University of Maryland, Baltimore County, UMBC for short. And due to department regulations, you have to be in the grad program. I think it's for 3.5 years. I had finished up my dissertation in 3 years, but due to the regulations, I had to stick around, hang out, for a semester. And I didn't really have that much to do. I could have taken up like a TA position, teacher's assistant. Maybe I could have even actually taught a class. But I was busy with some of the businesses I was involved in at the time. And I also thought, now's a really good time to take what I've learned in school and apply it to this blog. Like, let's share this knowledge. And that was awesome. But for the first year that I did it, I bet I only got like 2 emails a day, maybe. Maybe towards the end of the year, it started jumping up to 5 to 10. But whenever a new email come in, I was like, oh my God, this is great. Someone actually cares about what I'm writing about. Someone is reading this. Someone is getting value out of this. So for the first year, that was like my attitude. I'm like, this is great. We're finally getting some sort of traction. People are listening to what we have to say. Around year 2, we were probably getting close to about 30 emails per day from readers just asking general questions. By year 3, close to 100 emails per day. Year 4, maybe closer to 150, 200. And right now where we are with PyImage Search, we're getting well over 200 emails per day. In terms of blog post comments, like probably about 80 plus, probably averaging 100 as well. And it just gotten to the point where there's no way that I can personally keep up with that. And even as an entire team at PyImage Search, there's myself, there's David McDuffie. If you've ever emailed PyImage Search, you have seen David McDuffie in some way. He's my correspondence coordinator. He handles triaging emails, and he does all that type of stuff. There's Dave Hoffman. Hoffman helps me write content here at PyImage Search. I'll come up with an outline or some code and hand it off to him and be like, hey, Dave, please help me get this together so we can publish it. Then we have Abhishek. Abhishek has been so amazing with this new upcoming Raspberry Pi for Computer Vision book. He's helped us write code. And then the newest edition, Sayak Paul. Sayak has also been amazing. And without them, PyImage Search would truly not be possible. And I cannot mention that enough. That without this team, PyImage Search would not be possible. When I was at PyImageConf, I said, PyImage Search is not me. Yes, like you may see my face on the blog, but it's all of us as a large community. It's all of us together. I just want to make sure whoever interacts with PyImage Search understands that. So getting back to my original point is, we get so much email and we get so many comments that's really at the point where I cannot possibly process it all. I did the calculation, and approximately 70% of my day would be spent, or my entire week rather, would be spent answering reader questions if I tried to hit on them all. And at that point, it doesn't scale. It's kind of like writing code for an initial project, right? You get this proof of concept going, and the code that you write for that proof of concept may work for a week, it may work for a month, it may work for a year, but eventually you're going to end up ripping out that code and putting in a new procedure. And this is kind of what the office hours are right now. We've reached a point where we cannot scale continuing to answer these one-on-one questions. So in order to get some of my time back and be able to invest that back into PyImage Search, so like writing new books, writing new tutorials, and that type of stuff, we have to come up with a different way to handle these types of questions. And office hours, going back to what I said, I think the office hours are the best way to approach this. People are going to get their questions answered, and it gets to be shared with everyone, and the entire community benefits from it. For me personally, though, this year was like a really, really crazy year. It's kind of like the best year and also the worst year of my life, like kind of rolled into one. My wife and I got married last September, which is amazing. We're getting close to our 1-year anniversary, which I cannot wait for. But at the same time, my father was diagnosed with cancer around the time of the wedding last year. And he actually found out that he had cancer about a month and a half before the wedding was actually supposed to take place. And he didn't tell anyone. He didn't tell me. He didn't tell my mother. He told no one. So we get back from the honeymoon, and I see my parents about 2 weeks later, and we're just kind of just discussing what our holiday plans are. And I had volunteered to be like, hey, Dad, why don't you come up here to our house in Philadelphia and we'll hang out. He said, actually, I can't. I have an operation scheduled. I have prostate cancer. And that was a pretty massive wake up call for me. It's a pretty aggressive form of prostate cancer. And I've kind of mentioned it before, but I've had a pretty rough childhood. I grew up in a very broken home. My mother is a bipolar schizophrenic, and it created a lot of tension in the household growing up. While I'm not very close to my mother, I am very close to my father, and without my dad, I don't think I would be here where I am today. So again, for me personally, doing these office hours is a way for me to regain time that I have with my family. And if that makes me sound selfish, like, hey, like that's okay. Because at some point in your life, you have to make sure you take care of yourself, and that is exactly what I'm doing right now. And finally, I want to do these office hours to give back to the community. One of the first points I made was PyImage search, the help and the tutorials will always be free. And when I was back in grad school, I had a lot of time, a pretty good amount of time to invest in PyImage search in terms of providing free help. Over the years, that's obviously changed, and that's part of growing, But because of that, I have less time, and because of that, I want to be able to share something else. So I want to be able to share resources however I can. So to that end, what I'm going to do starting today, and ideally for every single office hours in the future, for every single question that I answer, I'm going to donate $50 to whatever the given charity is for the week. So for this week, I'm going to do the Prostate Cancer Foundation (PCF) in honor of my father. So for every question I answer today, I'm going to take $50 of my personal funds and donate it to the foundation. So if I answer 10 questions, $500 are going over to the PCF. So that's why we're here today. That's why we're doing office hours. I thought it would be useful to provide you with some of that context. So without further ado, let's jump into our first question. It's from Arjun, and Arjun writes, "Hi Adrian, I was accepted into the PhD program at my university last year. I have another year of coursework that I need to start doing research and writing my dissertation. I don't know where to start, and I feel a bit overwhelmed. Can you suggest me some research topics?" So first of all, congrats into getting into a PhD program. That is awesome, and you should be extremely proud of that accomplishment. Not a lot of people are able to even get into a PhD program, so the fact that you are there right now, amazing, and like take a second to be proud of yourself and to congratulate yourself on that. I obviously went to grad school, so I have some good opinions here. And if I've answered this question once on the PyImage Search blog, I bet I've answered it 100 times over the past 5 years. So I'm really happy that I get to share some of my experiences here. So for those not really familiar with a PhD program or a master's program, typically you start off with a year or two of schoolwork. It's usually an extension of an undergrad computer science program, only you do a lot more work in advanced algorithms. Typically, you'll have like an operating systems course or most certainly an advanced algorithms course, and then you'll start to take courses that are very specific to whatever your research interest is. So for us, in this community, that probably means taking like a 600 or 700 level deep learning course or computer vision course or data mining course. Once you take a year or two of courses, then you sit down and you finalize what your research topic is going to be. You normally find an advisor within your school, and you start doing your research. You do your research, you write your paper, you defend it in front of your committee, and then you're awarded your degree. So the first question I get is, Adrian, can you be my advisor? And while I wish I could, I cannot be your advisor because I am not affiliated with any universities right now. Not to say that I won't be in the future, or maybe like we'll even have like a PyImage Search University. That would be kind of cool. But as for right now, I am not legally allowed to be anyone's advisor because I don't have the proper credentials at the university level, meaning that I'm not employed at a university. I'm not a full professor at a university. And typically that's what's required to be the prime advisor on a given program. So with that said, like, let's get into the next part of the question is, what research topics should I do? I mean, computer vision is so so big right now. Like, and then you throw in deep learning, the intersection of computer vision and deep learning together. Like, where do you even start when thinking about a research topic? It's a really good question, and if you were to ask people this online, the first answer you're going to get is go hang out at like archive.org, and go look at the most recent publications, or go look at the ICML, International Conference of Machine Learning, or NIPS, or CVPR, Computer Vision and Pattern Recognition. Go through the abstracts of the proceedings from the last year and find the papers that interest you the most, and then kind of double down on those papers. Go back to the references sections in the papers that interest you the most, and go read those papers, and then follow the references in all of those papers and go read them. That's how you kind of build up this initial base of knowledge that you need to do in order to perform research. That is the typical answer that you will get. However, and this is a big however, that could be very bad advice because you haven't considered who your advisor is going to be yet. When you go into grad school, you have to understand that what you're doing is a means to an end. Your dissertation or your master's project, it does not have to be your life work, and it doesn't even have to be your best work either. It is just like everything else in your schooling. It is a learning experience. You take a course, and let's say you get a B instead of an A in it. Are you crushed like because you got a B? Do you think you're a failure because you got a B? No. As long as you learn something from that course and you recognize what you could have done better for the next time, that's the most important aspect, and that's what learning is. So when you start to think about your topics, and this is a really important tip, start thinking about your PhD or your master's level advisor first. Why do I say this? Well, it's a way for you to play the system to your advantage. If you pick a topic that your PhD or master's advisor is intimately knowledgeable with and has a lot of experience with, that is going to enable your advisor to give you that much more targeted research. And in terms of just pure, simple psychology, you know your advisor has a real vested interest in that specific topic. So if you go to your advisor and say, hey, this is what I want to study, I went and I read all of your previous papers, meaning the advisor. I read all the previous papers my advisor wrote. Then I can go into the office and I can have a really educated discussion with him. And I can ask him questions like, hey, I noticed in your results that you applied a support vector machine here. You know, I was thinking maybe if we could take this and maybe run a different feature extraction algorithm on it, or maybe let's try applying a deep learning approach instead of traditional machine learning. What would that do for us? Would that lead to a more interesting result? Would that lead to a novel result? And that allows you to kick this conversation off with your advisor. Your advisor is going to be so much more interested when that happens. And when your advisor is so much more interested, they're going to be able to give you so much more help. And the more help they give you, the easier it will be for you, the more help you have with writing your dissertation, and the more likely you'll be able to have your dissertation approved by your PhD committee. One of the worst things you can do is just kind of throw a dart at the wall and be like, okay, this person's my advisor, and walk into their office and be like, I want to apply deep learning to computer vision topics. And it turns out that your advisor doesn't know diddly squat about computer vision. They care about information retrieval, which is text search engines. And they'll be like, dude, like, what? Like, why did you choose me as your advisor? Like, I can't help you with that. And they likely will try and help you through the program, but they're not the best choice. So when you start going into a new school, first thing you should do is open up the faculty list for that school, for the computer science program, and then open up tabs for all of them and all of the papers they published. Go through their publication history and find the publications that most align with the stuff that you want to study. And once you've done that, that's when you go to the potential advisor and say, will you be my advisor? I read your papers, I read your work, and this is what I want to study. Will you help me with it? And if you do that, I promise you, your grad school career will be far, far easier. But going back to the beginning, if you don't know what topic you want to study yet and you have no idea, what specific area of computer vision or deep learning interests you the most, that's when you should go to your major publications, your CVPR, your ICML, read those papers, and then once you have a decent knowledge of those papers, then go back to your university, go back to the advisor list and read their publications, and try and find maybe some sort of happy medium between the two. And don't feel the need you need to go to grad school for 8 years or make this into your life's work, because it's honestly not going to be your life's work, and that's okay. There are very few people who have their graduate level research be something this totally mind-blowing Nobel Prize worthy. Like that is very rare. That is lightning in a bottle when that happens, and I really get discouraged when I see people try and do that in their own lives, because I think they're missing the bigger point. Grad school is a stepping stone to whatever is next in your life. Go to grad school, pay attention, learn a lot, but have this self-discipline to say, okay, enough is enough. I need to wrap this up and move on to the next stage of your life. Don't feel the need to be in school for that long of a period. Instead, find the right advisor, and then once you have the advisor, pick a topic that they are very well knowledgeable in. It'll make your life so much easier, I promise you. So I hope that helps you, Arjun. If you have any questions about that, obviously feel free to email me. All right, so this next question is from Pranav. They write, I'm on question 2 in the Pyramid Search Gurus course. In the cropping quiz, it asks, what is the most appropriate NumPy array slice to crop people from a background in this specific image? How do I determine this answer? How do I map what I am viewing to actual pixel coordinates? So the question here is related to the Pyramid Search Gurus course, and I believe it was the cropping lesson. So if I open this up, here is the image that Pranav is asking about. This is a photo of me from probably 5 or 6 years ago. And I have the code right over here in our office hours. Hold on just a second. The computer with my notes just decided it wanted to log me out for some reason. So here we go. Here's the cropping code. And if I launch a Python script, we'll see what this code is doing. Okay, so I'm going to launch the script. Here is the original image, and here is my cropped face, and then here is my cropped body. Now, looking at this code, you're like, Adrian, how in the world did you extract these regions? There's no machine learning classifier, object detector going on. How did you know these coordinates were the coordinates for your face, and these coordinates are the coordinates for your body? And if you look at the code, all this is hard coded. These array slices right here. So I'm gonna use this as a really good teaching opportunity. Hold on, looking at my Slack notes. Make it bigger, please. We can even see the file on the full screen. Let me see if I can zoom in. How do you zoom in with Sublime? Is that even possible? There we go. There we go. Now it's much larger. I hope that helps everyone. So let's dissect this really, really quick. So how do you access individual coordinates in an image? So if I wanted to get a pixel, I may say pixel equals image 0, 0. So this is the coordinates of the image, assuming that the origin is up here in the top left corner. If I were to execute this code, I would get the pixel located at 0, 0. Now, this is where people tend to get a little confused, because they think, oh, x equals 0 and y equals 0, right? Like that's how we're actually supplying those coordinates. No, it actually looks like this. The y comes first. And why is that? Well, when we write a matrix, we write it in terms of width by the height, right? Like that, right? So if we're going across like the width, the width is actually your number of columns, and your height is your number of rows. Number of columns is actually y. That's a little non-intuitive and something that like really tripped me up when I started playing with OpenCV. Like once the I guess it was OpenCV 2.4, once that came out and we had NumPy array support, like I couldn't wrap my brain around that. Like, why is that true? And then I finally figured it out. I'm like, oh man, I feel really stupid right now. But hey, like it's one of those things, like you learn it and you never forget it. And like this is one of those things. So if I wanted to access the coordinate at say 50, x equals 50, y equals 100, the code actually looks like that. That's how you access those individual pixels. If we look at NumPy array slicing, how we actually extract these coordinates, the syntax looks like your start y, your end y, your start x, and your end x. That's what this code is doing. So it's saying, hey, start at y equals 85, end at y equals 250, start at x equals 85, end at x equals 220. So that's what this code is actually doing. To get back to the question, you have to wonder, hey, how did you actually determine those coordinates, Adrian? Like, what did you do? What kind of black magic is going on over here? And to answer that question, use whatever photo editor is available to you, or whatever photo editor that you like. I personally use Photoshop. Back from my web design and web developer days, I learned how to use Photoshop, so I feel pretty comfortable with it. If you're not a Photoshop person or don't know how to use Photoshop, GIMP is like a really great photo editing tool that you can use. I don't think macOS Preview has pixel coordinate locations in. If I'm wrong, please let me know, because I really love to know that. So let's get back to the question. I'm going to open up this input image. And there we go. Now I have the image opened. It may not be able to come through due to the fact the zooming of the browser or the screen in Facebook Live, but I'll try to explain what I'm doing as it's happening. So if you can see this here, this is showing like the X and the Y coordinates of wherever my mouse is on the screen. So if I move over here, like closer to where, say I was going to draw a bounding box surrounding my face, I would start over here and looking at my screen, like looking at Photoshop, the info panel right now, I can see that X equals 95 and Y equals 99. So I'm going to go back to our code over here, and I'm going to just make a copy of this. So what I say, so let's do this again. X is about 100 and the Y is about 95. There we go. Now I'm going to move my mouse down here, and I see Y is about 250 and X value, let's see, is about 225. Let's call it 225. So I'll code it like that. Go back to the Python script, execute it again, and you can see I've essentially cropped my face from an input example image. You can apply the same method to any other part of the body of the image, whatever you want to extract. The key here is that you need the original image. You need to load it up in whatever photo processor you feel comfortable with. Again, I know how to use Photoshop, so that's my tool of choice. You may want to use GIMP. There's other tools, other image editing tools available to you. Just Google your operating system name followed by image editor. There'll be tons of results. If you don't have an image editor on your computer, I would go for GIMP. GIMP is free and open source and works on the vast majority of operating systems. So that is how I manually find pixel coordinates in an image. The next question here in office hours builds on that. It says from Ilian. Ilian says, "Hi Adrian, I absolutely love the PyMixReach blog. I've learned so much from you and your clear tutorials. I'm trying to extract motion from a very long video, 10+ hours. I need to scan only a specific small region of the video and cannot figure out how to do that with Python and OpenCV, and not have to kind of pre-snip the video and export that video as a new video and then process only that clip. So Elaine asks, how would you approach this, Adrian? How would you go about it? That is a really good question. I wanted to answer both this one and the previous one together because they obviously go hand in hand. So let's open up Finder real quick. Here is an example video that I'm going to work with. It's just video of some highway traffic. And let's pretend that, hey, we want to only really process like the left region of this lane. So like starting up here, down here, we don't care about this side of the road for whatever reason. How would you go about doing that? Would you basically do what Alien said? Would you open up like a video editor like Camtasia or QuickTime or Windows Media Player? Is that even a thing? Does Windows Media Player still exist? I hope not. That was a terrible editor, or terrible audio visual player. God, it's been 10 years since I used Windows. I don't miss it. Anyway, let's say we only want this half, the left half of the video, and we don't want to have to put it in the video editor and export that specific region of the video. Is there a way for us to do that programmatically? So let's find out. I'm going to open this one right here. I'll change Sublime so we can all easily see the code. This is just some super bare bones code here, right? We're going to supply a path to an input video. We're going to grab a pointer to the video stream, and we're going to start looping over frames of the video. If the grabbed boolean is false, then we know we've reached the end of the video. We'll break from it. Otherwise, we're going to resize the frame, show the frame on our screen, and release the video pointer when we're done. So if we actually run this code, it'll look like this. Here we go. There you can see the video moving. But how do we define those XY coordinates of where we want to crop? How do we go about doing that? Are we gonna like take a screenshot of like this frame and then opening up in Photoshop and do stuff like that? Well, we could, but I just took a screenshot of it. I'm going to show you why I don't like this approach, because depending on your operating system, it may do some weird stuff. So on Mac OS, by default, it creates this like drop shadow surrounding whatever you screenshotted. So here's like the window. So if I hover over here, like it says it's x equals about 117 and y equals 116. Like we know that's not true because the origin is actually 0, 0. Like, are we going to do this math and kind of subtract it and figure it out that way? No, there's better ways. And just to be clear, like, yes, I know you can turn off the drop shadow screenshot via Mac OS. Like that's not really the point. That was just me illustrating why you might not want to do that, because different operating systems have different defaults. So what I'm going to do here is I'm going to import the sys package. I'm going to kill off our script immediately, and then I'm going to do cp2.imWrite, name it test.png, and that's the frame. Now I'm going to run this again. The script is going to immediately exit, but if you check here, I now have this test.png file. So if I open that test.png file over here, then I'll be able to extract these coordinates. So let's delete this. We'll say frame equals frame. We know x equals this, y equals 0, and x equals 0 is our starting coordinates, because that's the upper left origin. If we go down here, let's see, where are we at? Looks like x equals about 250. And then y is 280. So again, just applying really basic NumPy array slicing. And if I go back and I run the script again, look, lo and behold, I only have the left-hand side of the frame. And more importantly, I'm not going through and I'm not loading this video into some sort of video editor, cropping out only the region I want, and then re-exporting it. This is all being done on the fly. So it's very efficient. It's not as manual, and it makes your life a lot easier. So I know this seems like a really basic question, but I'll also say that it'll only seem that way once, because once you see it like this, you'll never forget it. And also, primary search is a teaching block, so there really is no super basic question here. We're all here to learn, and we can all learn new tricks. Okay, so going on to the third question from Lad. They write, I'll try to explain shortly what I need. My application, it's a non-professional project, C++ only. We'll use OpenCV and perceptual hashing for comparison of a few photos of the same person. And I really want to highlight like the same person, because we're gonna touch on that in the rest of the question. The first photo may be done yesterday, and the second photo may be from 5 to 10 years ago. I have to find a correct algorithm for the hashing calculation. I'm not sure that resized image of 8 by 8 pixels may be good reliability, or I may be missing something. So this question came after I posted this latest tutorial, I guess it was actually 2 weeks ago, on using OpenCV and image hashing to build these build image hashing search engines. So with an image hashing search engine, what you're trying to do is find duplicate or near duplicate images, okay? And I'll show you an example of that from our result here. So this in a new tab, and I'll make this bigger so you can see it. On the right here, or on the left rather, this is our input query image, okay? We want to find duplicate or near duplicates of this image in our data set. And once we ran our algorithm, this is the duplicate image that it found. Now, obviously, this image has been manipulated and changed in a little bit of way, but again, that goes to the point of quote-unquote near duplicate. This is a different problem than what the reader is asking here, because they're looking for the same person. And as we know, like our faces can be oriented differently. Like I could turn my head this way, I can like turn completely around, and depending on like the orientation and the viewing angle, my face is going to look slightly differently. Like I'm still me, it's the same face, but different orientation. So that's actually not a problem, or it's not an image hashing problem rather, because as soon as you start changing the viewing angle or introducing a lot of differences in the input image, the hashing technique is not going to work. So instead, what you want to do is apply face recognition techniques. So I would actually recommend the 2 tutorials I wrote on basic face recognition using pre-trained models like FaceNet to construct these 128 dimensional embeddings of the face. So the first one here is OpenCV face recognition. The other one is face recognition with OpenCV, Python, and deep learning. Both of these tutorials will show you how to build a face recognition system, but you can take it and turn it into what Vlad actually wants to do. The other tutorial you want to look at is it popping up here? No, I have to do another search. Is the face clustering tutorial. Again, using these 128 dimensional face embeddings. And you run dbScan, which is a clustering algorithm on top of them. And what actually happens is you get groups of faces that are naturally clustered together. And ideally, the faces that belong to each individual cluster are the same person. So to go back to the question here, if you do image hashing, it's not going to properly work, because you're naturally going to look quite different 5 to 10 years from now than you do now. I mean, that's just basic biology. That's how we age. And more to the point, your face may have been captured under different lighting conditions, different viewing angles, all sorts of different things. So if you go about this project, Vlad, don't use image hashing, okay? Go and check out these face clustering tutorials and these face recognition tutorials. They're going to be much more in line in what you're trying to accomplish. So let's see. Our fifth question has to do with shoes. And the reader asks, I'm going through the starter bundle of deep learning for computer vision with Python, and I came across the image hashing search engine that Adrian wrote, which is similar to my project. I want to know how we should take the pictures of shoes so that it'll be searchable via the VP tree hash. Would you guide me and show me how to create a data set of images so that we place the camera over shoes, it'll search via its hash. So the way I kind of envision this, this project working is maybe you have like a whole data set of shoes, right? So like you have this big like collection of shoes, and you whip out your smartphone and your friend is wearing these really awesome kicks, and you're like, dude, where can I get some of those awesome kicks? And you take a photo of them and it analyzes the photo, and then it finds similar or ideally identical shoes online. This is a hard project to build. 100% possible, absolutely doable, but again, it goes back to the previous question that I answered. Image hashing is the wrong approach for this. You can find duplicate or near duplicate shoes. For example, like for this image, if we had this image like in our database, and then maybe like I copy and paste it in Photoshop, and then like remove like the upper corner up here, or maybe like change the contrast or the brightness, and you wanted to find like this identical image in the database, yes, that is a perfect use case of VP trees and image hashing, and that's exactly when you want to use them. If, on the other hand, you want to find similar shoes to this, and you know that the image is not going to be visually identical, meaning it could be captured under a different viewing angle, or lighting conditions, or maybe the shoe is like on their foot versus like in your hand or on this nice clean product shot background, then you need to leverage different algorithms. What algorithms should you use? From a traditional computer vision perspective, I would recommend key point detectors, local invariant descriptors, and key point matching. So like the most popular one of them all is David Lowe's SIFT, and I'm sure a good amount of you are pretty familiar with this algorithm, or at least heard of it before. This algorithm is available in OpenCV in the non-free module. So that means like if you want to use SIFT, you have to compile with the non-free module enabled, and you have to have the OpenCV_contrib installed as well. So if you follow my tutorials on Python Search to install OpenCV, you should be good to go with that. If you don't, make sure you go through my install tutorials, and for reference, they are over here, up here on the main navigation under OpenCV install guides. Anyway, getting back to the question, what I would recommend you do is do key point matching. We cover that both in Practical Python and OpenCV, and then there's like a ton of modules in the Python Search Gurus course. Like if you scroll down here, you'll see module 10 is all on image descriptors and different types of detectors and descriptors and binary descriptors, and how you actually match them. So here, to show an example of this, I would actually take something from Practical Python and OpenCV, and in this specific chapter, it's a book cover recognition chapter, and I have this database of book covers, right? So here are all covers of books that I've downloaded from the internet. And then here are my query images. So here's like an example image that I would want to find in that previous directory. And here's an example of another book cover. Again, I want to find that same corresponding book cover in that data set. And you may decide you want to use an algorithm like this, like say you're building like a smart Amazon like shopping engine thing, where you go to Barnes and Noble and you're like, do I want to buy this book for $25, or like is it cheaper on Amazon? Instead of manually typing in the name of the book and the author, you just whip out your phone and take a photo of it, and then you're able to automatically find it online and find the best price on it. So that's the general motivation. And the same thing is true for like our shoe recognition project, right? This image right here is not the identical image over here in the covers directory, right? Is it in here? Yeah. So like here you can see these, like they're obviously the covers of a book, but they're not the same exact image. So image hashing would not be the best approach here. Instead, you want to do this key point matching technique. And what key point matching does is it detects a whole bunch of key points on your two images. So I'm going to open up this so you can see a little bit better. So it detects like specific regions that are, for lack of a better word, I'll say they're visually interesting according to the algorithm. They may not look visually interesting to us, but to the detector and the descriptor algorithm, these specific points are interesting because they can be replicated ideally in another image. So here we can see some examples of what they call key point correspondences, where we've matched key points from our original image over here in the covers directory to our query image, and we're able to automatically find that. That is my suggestion for this type of project, is you want to be able to use these key point algorithms. The problem is it doesn't scale without a little bit of magic. If you were to apply this exact algorithm, it would be linear in scale. So if you had a database of 1,000 images, you would have to do 1,000 matching, 1,000 matches for each of those images. If you had a data set of 1 million images, you'd be doing 1 million comparisons. And if you had 10 million, you'd be doing 10 million comparisons. That's a lot, and you don't want to be doing that, because like it could lead to like the search engine that takes like 30 minutes to come back with a result, and like nobody has time for that. So instead, what you could do is use a bag of visual words model. And I'm not going to go into that because we're running out of time. If you want to read about it, it's in the course. But by using a bag of visual words model, you can actually scale these matching search engines up to millions and millions of images on a machine with like 64 gigabytes of RAM, which when you think about it is like nothing for a server. To have like 64 gigabytes of RAM and be able to like handle millions of images and all in memory, that's pretty sweet. So again, going back to the question, you can build this shoe search engine. It will not be an easy project. I would suggest you take it in steps. Get a really simple data set, like probably something like what we see here on Google Images, where you're dealing with product shots and not actually shoes on people's feet, because that's a whole another can of worms. Get the key point matching without the bag of visual words, just a really simple model. Get that working first, and then from there you can start worrying about scalability and using the bag of visual words model. What I'll say is that if you want to do this for people's feet, you want to look into instance segmentation models. I know that was a question someone was asking that in the chat. They were asking for instance segmentation and those types of algorithms. So like instance segmentation, real quick, would be your mask, RCNN, UNet, models like that are capable of creating these pixel-wise masks of the input image. So like your foreground, like that's all one pixel or one mask, and then like each individual object in the image has its own mask as well. So by using instance segmentation, you can actually find like all pixels in an image that belong to a shoe. And if you find all pixels in an image that belong to a shoe, you extract that region again using the NumPy array slicing techniques that I showed you in this post. You extract that region, you apply key point detection and local invariant descriptors to that region, and then you can go over here and use this matching code to actually recognize or find visually similar shoes along the way. If you want to scale it up, that's when you start worrying about the bag of visual words model and how to actually do that. So how much time do we have left? We have about five minutes left. Let's see. Looks like we have a question. How about Keras data augmentation on a select group of images for creating a data set of shoes? Okay. I'm trying to think probably the best way to answer that question. The first thing I would have you do is go to the PyImageSearch blog, and there is a tutorial here on data augmentation. It's from July 8th, 2019, and explains data augmentation with Keras in a great bit of detail. So I'm assuming the question here is, I have a data set of images and I want to expand my data set of like shoes images. Let's say I have a data set of 500 shoes images and I want to turn that to a data set of 10,000 shoe images. Is data augmentation a good technique to apply? Realistically, no. And the reason is there should only be one ground truth image in your original data set. So for each query that you input, you ideally want to find that same corresponding or visually similar image in that data set. You don't want to expand your data set by applying data augmentation for things like building image search engines. And the reason is storage. You ideally want to describe this image once and have it be invariant to rotation, to translation, to shearing and whatnot. If you apply data augmentation and increase your data set by a factor of n, that means that your in-memory requirements when extracting features and indexing has also increased by a factor of n. You want to minimize your memory usage requirements as much as humanly possible. So while you could use data augmentation to generate query images, you wouldn't use that to increase the size of your original data set. That would actually really create a lot of problems and not something that you would want to do. So let's see, we're running up on time here. We got a little bit of a late start because first time I've done this, not a bit of an issue trying to get screen sharing to work properly. So before we get into any other questions, I'm going to go ahead and call this office hours session. Please give me your feedback on it. Once we hop off this session, open up your email client and email me, adrian@piimagesearch.com, and just let me know what you thought. Was this helpful? Is this something you want to see more of? Do you get value out of this? Are there types of questions you want me to answer? Do you prefer it more where I'm just like, the camera's facing me and I'm just talking to you and telling you my opinions on things, or do you like it more when I'm opening up an actual editor and coding along with you and teaching you things? Do you like a mix of both? Again, this office hours is 100% brand new. It's something we've never done before. I certainly want to continue doing it if you're getting value out of it. And if you're not getting value out of it, then I won't do it. But again, I have no way of knowing unless you tell me. So please take the time once this call ends to give us your feedback. Your feedback, as always, shapes PyImage Search. I listen to what readers say all the time, and what you say impacts me and the business and what we teach you dramatically. So please take the time to do that. I appreciate all of you for being on this call with me. And hopefully I will see you next Thursday, same time. See you guys later.